Good afternoon. First, I would like to thank everyone that came today to listen about cryptography. I can barely get together my family and friends to speak about cryptography, so it's amazing, it's fantastic to have you guys here to see developers interested in it. The main goal of this talk is because I got a little bit pissed off and sick about people saying that cryptography should not be done by developers, only by experts. And I truly believe that most part of the time, we as developers, we are alone. We don't have the privilege of having an expert on the next door. So that's my motivation behind this talk. For people who don't know me, I'm Abstract J. I work with software development for 13 years. Before that, I used it to be a sysadmin, building firewalls and collecting funny stories. For years, I contribute to open source. I believe that that's the way to make it. It would be silly to tell about the importance of making open source in such conference. But at the same time, open source is the thing that makes our software strong. Some people argue that open source make software weaker and less secure. I truly believe that's pretty much bullshit, because if you're writing software together with people around the world, you can make it better, more valuable. So today I work for Red Hat at the GBoss division. And this lab, I worked for almost 5 years. And today I'm pretty much focused on Keycloak. And for people who don't know, Keycloak is pretty much an identity and access management solution. It has identity federation, identity brokering, social logins, and it's pretty much security that don't suck. And if you are interested after the presentation, you can talk more about, or if you can just visit the website. I'm very passionate about security and cryptography, but at the same time, I do not consider myself a cryptographer. And also, I'm not like a hacker in the hoodie trying to defeat the US government. I'm pretty much just a developer hammering things like everyone in this room. So my main goal here, and I would like to make a disclaimer, is pretty much not to teach you how to do things. I believe that everyone in this room, I'm 100% sure that you guys know what you're doing, right? The main goal here is to share the knowledge in this field, and I really have my hopes that we can make things better and build a community around this field. So let's speak about cryptography, right? That's our goal here. Cryptography is like our solution to our problems, but it's only part of the solution. It won't solve all the problems that we have on security. Security is made by several factors and can be part of the solution and also can be part of the problem. So it's really, really hard to define what is cryptography. So I went to the dictionary. So pretty much the dictionaries say that this is the study of codes or art of writing and solve them. And this is amazing, right? Because it says nothing. So I went to the crypto books because we have well-known crypto books like Cryptography, Engineering. And it says that cryptography is the art and science of encryption. It's pretty much obvious, right? So I decided to create my own definition. It's pretty much the process of scramble sensitive data in the way that a person with bad intentions and more free time than you cannot read. That's my definition. So to understand cryptography, we have to talk a little bit about history. In the past, in Egypt, was pretty much focused on communications, right? So we had hieroglyphs, we had visionary ciphers in Rome, was pretty much like a substitution cipher. We have Enigma machines during the World War. And later, we have the DAS algorithm created in '74, and with block size of 64 bits and short key size that can be subject of brute force. So still today, people make use of DAS, and this should never be used in production because it was proven that can be broken in 22 hours, right? So if you go to EFF, you're going to find out that it was already broken. So, but in the past, we had something really important. We have very limited processing power, and people use it to care more about security, more about privacy, because depending on the situation, it could destroy a civilization, because if people could intercept messages and decode messages, it could pretty much destroy the other civilization, right? So it was a matter of survival. But today, it's not the same thing, because we have hardware with more processing power. We have mobile devices more powerful than computers in the '70s. We have celebrities sharing naked pictures. And seems like people today, ordinary people, I'm not talking about developers, people today do not care too much about privacy. The concept of privacy changed a bit, because today we know what people ate, we know where they go, we know which pictures they shared. So our daily basis is pretty much surrounded about cryptography, even if ordinary people don't care about it, right? We have ATMs, voting machines, we have mobile phones. Sorry. And now we have a broader scope. It's not only about secret communications. Today is pretty much more about secrecy, data integrity, authenticity, and the reason why ordinary people today started to see security as a thing is pretty much due to the leak from Snowden, right? Because before, people wasn't aware. What's cryptography? We don't see it, we don't touch. And what my friend says is that security is pretty much like the Georgia Binks of software development, because if something goes wrong, you're the one to blame. If things go right, no one will notice, right? And if you go to a company that has a legacy already running, people say, don't touch, because you can just break all the things, because you're not the expert. And I fully disagree about it. We should understand what we are doing. We should share the knowledge. So in theory, crypto was supposed to be simple. Who in this room already tried to read the JCA documentation? Yeah, I tried, and it's really, really hard to understand. And I'm not saying that I understand crypto better because I'm smart, because I suffered 4 years to understand which algorithms am I supposed to use, which ciphers are the best or not. So it's really hard, and the documentation can lead you to failure, because sometimes they recommend things like MD5. And we have to be really careful and have critical eyes about such things. So it's really hard to get it right, because I assume that everyone in this room are not fully dedicated to security. As me, I'm a developer. So you have to look into other things like scalability, you have to look at the database, if things scale or not, how to integrate with other systems. So it's really hard to get it right, and most of the time we were just shooting in the air, hoping for the best. We go to the Stack Overflow because sometimes we have no idea what to do next. So even very skilled people, like for example, we have Komodo, that's a CA that had a leaked breach, and pretty much all their certificates were compromised. We have Western Digital, for example. Even the big players like T-Link, I could spend the whole day speaking about leaks here. even very skilled people with great knowledge, they can fail because it's not a subject simple to understand, including myself. So we had this car hacking. Pretty much it was Toyota being hacked by these guys. We had the famous Heartbleed. And added to that, we also had our users that they truly don't care. They truly don't care about cryptography. I talked to my wife, why don't you put a clever password in your email? Oh, because pretty much it's easy. 4 digits is like a face palm, but for her, it's OK. So these are the top 10 leaked passwords from Adobe, right? And I'm not lying. If you go to Google, you're going to find it. And some of the developers may argue that, but the user is stupid because 1, 2, 3, 4, 5, really? No, it's not only about the users, because we as developers, we have the duty to make it better. So if these passwords were leaked from the database, it's because Adobe was storing it. And you should never store passwords. That's one of the things. So some people say that they have nothing to hide, but I've got a few things to be ashamed. So I found this quote funny because several people say, but I have nothing to hide. Why encrypt it? Not really, right? Because if you want people to respect your privacy, and even if you don't care, you should respect your customers' privacy. So we have a surveillance program, right? That's pretty much why we're discussing crypto, because it became very, very popular. And it's a so critical subject that I took this from Veracode. And if you look right here, 60% of issues with financial services are about cryptography issues because people do it wrong, right? It's from the financial services. So that's really, really something to be concerned because other things are information leakage, cross-site scripting, but is the top 2. So we can see crypto as a problem or a solution because if you see a thing that was not supposed to be touched, it can be a problem too because if you take the Moore law, the hardware that we have today are growing fast. So algorithms that we have today can be broken. Parameters that we use today must be revisited. So I truly believe that books are an amazing resource for self-education. And we have several good crypto books outside. Most of them are involved of deep math. And I truly believe that that's the reason why people commit mistakes, because we read the books, at least me, I feel like an idiot because it has overcomplicated math, and I just wanted to encrypt data. I don't care about overcomplicated math. It's amazing, but I had to solve my problem fast. So some people feel self-confident about their knowledge on math, and they start to ask questions like this. Why should we roll our own crypto? And the best advice that I would give to you guys is never do that, because doing that is the worst thing that you can do, because we have NIST that runs a competition at every new algorithm or encryption scheme that exists. They have a competition to see if it can be defeated or not. We have the CWE database. So every time that if you are in doubt about, should I implement this password validation like this or like that, you go to the CWE database and you can research about the common mistakes. So how crypto is done nowadays, right? We pretty much have these libraries is crypto, JavaX Crypto, Bouncy Castle, Jazip, Keyzar. For Node.js and Ruby, OpenSSL. We have Web Crypto, Crypto.js, JCL for web. And for Java, it's like Bouncy Castle, for example, is like something from 10 years ago. And it's not too much updated. But it still works. It's amazing. But we have to be really careful about what we use, and because these libraries give you full control, right? Because you just provide the parameters, and they don't care if they are right or wrong. So it pretty much give you full control. So full control can be good or can be bad, because if you think, sometimes you think that you're doing a great thing, and it's really valuable that a developer is concerned about cryptography. But sometimes you think that you're doing the right thing, and you're not truly protecting the system because you're not truly encrypting. So let's get our hands dirty, and I'll show to you guys some things that I know and would like to share with you. So I created a really badly designed notes app. It's really ugly because it's a Java class that generates a note in JSON file. And the goal is to show some concepts to you guys. So I have Alice that would like to write her notes and store in some place. I have Bob, and I have the eavesdropper, the guy that wants to defeat the both. So I have a really simple story here. As a user of this app, Alice wants to be able to create and share new entries. So that's pretty straightforward. Yes. So it's not mirrored. So let's try this. That's not cool. Just a second. I want to mirror because otherwise I have to code there, and it's not fun. So this is my app. I have my hopes that everyone can see this. It's completely stupid. I have a title, I create a new entry, and this is my JSON file, right? It's pretty straightforward, really simple. So I would like to share my notes between Alice and Bob in the way that someone in the middle cannot intercept it and change the message. So there are several ways of doing it, and pretty much some people, some might be obvious for some of you guys, but I would like to show some of the things that I see on the internet. And pretty much some people will make use of MD5, for example. Like, for example, I create the story, and the second story is, as a user of this app, Bob wants to be able to verify the integrity of these files. There are several ways of doing that. Some people do using hash, right? So we have, okay, that's awesome. And I cheated because I created several branches to show to you guys because we have too much to discuss. And this is pretty much what happens. Now I have my MD5, right, to check the integrity. But the problem is with MD5, I have things like this. Let me show to you. This is one of the CWEs, right? MD5 is already considered broken and risky. So I found a really good example on the internet is the comparison about these two pictures. So I got these two pictures. If you look at MD5 of them, they are pretty much the same thing, right? So that's the reason why we should never make use or trust in MD5s because it's not resistant to collisions. So aware of that, what I do is pretty much to move to SHA-1, right? So this is the same class. Now that I know my JSON file, the best way to check the integrity of this file would be to just generate a SHA-1, like we have, for example, for Linux images. And pretty much we validate here if the digest is equal to the generated digest. So pretty much if I run this, I have the SHA-1 here, and I know this is valid. Another thing that could be done to test is to corrupt my digest, right? So if I try to corrupt my digest here, and you run it again, you get this, right? So pretty much you can do it with SHA-56, for example. So you could generate a SHA-56 or whatever. So I read some news about that SHA-1 is starting to getting broken. So if I would totally change to SHA-56. So moving forward, you can go to this website, and there are several. There is a paper explaining why how SHA-1 can be broken. So what about include a salt? Because, for example, people do it for passwords, right? They create a SHA and concatenate with a salt. So this is the other CWE, is password with insufficient computational effort. So it's pretty much, when you do a hash with a salt, it's just a hash. So hashes were made to be fast. So if I just rent 5 machines on Amazon, I can run hashcat in an attempt to break it. So you can prefer the other SHA-55, SHA-512, or things like this are all good choices, but they are only to check integrity, not for passwords. So this is an example of a distro. So sorry, as a paranoid, I would like to only integrity, but also authenticity. And this is found, like, for example, in OAuth protocol. You can check the authenticity of the message, of the token. So what I do is I can try. Sorry. So I can try AgMac. So the principle of AgMac is that I have a shared secret here, right? And pretty much Alice and Bob will share the same secret. So this is the way to guarantee some integrity between both. So here I specify which hash I want. So pretty much I have a shared secret and a hash. And here I just specify my secret key. So that I did right here. Sorry. So what I do is, all right, I check the integrity. I wrote my AgMac, okay? And I have my AgMac here. It's pretty much a hash based on that file, based on the shared secrets. And what I can do here, if I try to introduce a key that was not provided by both parties, for example, here, I have my dummy secrets. I will try to check the integrity with that shared key to see if, for example, an eavesdropper changed my message, but the eavesdropper does not have a way to check the integrity because it does not have the shared secrets. So If I do this, shared key is not valid because it's the dummy. If I do this, yes, it's valid. So this is the way to check integrity and also authenticity. But the problem is the fact that the problem was not solved yet because a man in the middle could intercept the message and read that message. So I just guarantee integrity here. I just have integrity. So as a user of this app, I want to add integrity, authenticity, and secrecy, and hide my entries from NSA. So we have several modes of operation. One of them is CBC. Something that's worth to mention is never make use of ECB, and I will show to you guys why. So you may notice that now, if I want to encrypt my data, it's pretty much, I have my entry here. I create a key generator. I say that the protocol is AES, okay? And I just ask to generate the key. So every time that you generate the key is the key generator, yes, the key generator will automatically generate an IV. I will explain what it is. So here I encode my key in Nexa, and I just say which kinds of protocol, modes, and padding, right? And I just say that I want to make use of the encryption mode. So you can make use of several modes with the same protocol, and you just keep this line. So by the end, I just run cipher.doFinal and encrypt the data. So it's going to look like this. So I have my encrypted data here. It's pretty much an Nexa because it's human readable for us. It's not just bytes, and it's easy to visualize. So the use of padding is pretty much to fill the last block until it meets the cipher block size. And let me explain a little bit about the modes of operation. So pretty much for this, we call this symmetric encryption, where Alice shares a key with Bob, and both they can encrypt and decrypt the data on both sides, but they share a single key. So the modes of operation, ECB, like I mentioned, never use that. And if you go to several documentations, like I found it at JCA documentation. I'm not here to criticize the documentation, but pretty much I found it. There is an example with ECB. And the reason why ECB is really bad is the fact that if I encrypt a key in a plain text saying hello world, it is going to produce the same ciphertext. So an attacker, a man in the middle, an eavesdropper, could guess what information is that. For example, think about transactions. And if the attacker realized that that transaction represents like a transfer, he could just do a replay attack. So that's the reason why you should never use ECB, because there is no randomness. So people joke about it because everyone knows that ECB mode is bad because we can see the penguin. There is some test encrypting this image, and you can see the penguin. So another operation mode, like I mentioned, is the CBC. Why CBC is different? There is an initialization vector that's random, and based on the key, the IV, and the plain text, the data is encrypted. And every time that you go to the next sequence, the IV must be different. Something that I found on the internet is the fact that people just hard code it. And this is really bad because it was going to produce the same outcome as ECB. So let me show to you So I encrypted the data. I would like to show to you how it works. Sorry. So this is not what I want. I want this. So one of the common mistakes is the fact, like I mentioned, that people do not specify the IV, right? Or the IV is hard-coded. And if the IV is hard-coded, it's going to produce the same outcome all the time. I can show to you guys. So, okay. So here, you may notice that if I try to corrupt my ciphertext, can you see this? Nothing will happen. I can just be in the middle using CBC mode, corrupt the data like a transaction, change the data, and the other side won't notice because pretty much CBC does not check for integrity. So what do you do? The best alternative, and is the mode that I truly recommend to you guys make use of, is GCM. So what GCM does? So you can see that I just changed the mode here, okay? Always make sure that the IV will be random. Please never reuse the IV. Never, never, never. So I'm going to encrypt my data. Okay. So it's pretty much here. I generate the key. I have my secret key. Here I specify the GCM parameters that's pretty much based is the initialization. So it's 128, for example, based on my key. I have a nonce on GCM that's pretty much to check the authenticity and integrity. Okay. So I am going to encrypt the data here. Okay, was encrypted. It's pretty much encrypted. So let's switch to another branch. So if I go here, and I want to decrypt, it's pretty simple. So it's encrypted. So let's try to corrupt that data, okay, to see what happens. So as you can see here, it's the same thing that I did with CBC, right? I'm trying to corrupt that data. So if I do that, what's going to happen? It's going to fail because it checks the integrity of that data. So it's going to say that's bad tag mismatch. So it pretty much does not match with what we agreed, okay? So if you have plans to use encryption, symmetric encryption, make use of GCM. Another thing that I'd like to show you is this is the CTR, and again, there are several modes to operate. And if you ask me which one should I choose, is GCM, okay? Just stick with GCM. And another example is, as a user, I want to have a protect entries. So this is the classical example where people try to validate passwords. And some people compare hashes, some people concatenate with assault or something like this. And my advice as a developer is to make use of KDF functions. I will show to you guys how to do that. And KDF functions you can use for password validation, or you can make use for encryption because it generates a private key. And here I have my password that I specify. I have my secret key factor, which I say that must be used with a KDF function, and a hash, the SHA-1. Okay? So I generate a random number here. And it's pretty much, I specify which password that we have. That's the classical example where I mentioned for Adobe. Because you do not store the password, you just recreate that hash based on the input from your user. And based on that, you can compare hashes. So here, you're going to see that there is a salt. It's truly random. I have the number of iterations. It's like you write, let's be a little bit rude here and say that's pretty much like write a for loop with 20,000 of iterations over that hash. So it's really hard to break, even with powerful computational efforts. So this is the size of the key, okay? And here it generates my secret key. So like I said, JCA documentation recommends MD5, and it is a really poor solution. So here, what I'm doing is making use of this key to encrypt, for example, with CBC. Like I mentioned, you can use it for compare passwords. Also, you can use it to encrypt the data, like a private key. So it's a password-based encryption. So oh yeah, because I don't have the file. But trust me, it works. Yes, it works. So this is the password-based encryption. And the last story, I hope, is I would like to share my entries with a friend without exposing my keys. So as some of you know or not, this is a public key encryption. So pretty much, I no longer share my private key with my friend. I just share the public key. He encrypts that key and sends to me the data encrypted. I decrypt it with my private key. There are two ways of doing this. One of them is with RSA. So one of them is with RSA. You just generate a key pair here, right? You initialize with the key size. And you have a public key from Alice. You have a private key right here. And with that public key, sorry, you can encrypt or decrypt data, right? It could be a Bob public key, for example. So it's pretty much like this. It's the same thing. The only difference now is that I no longer share my private key. So, for example, I could do this with 509, for example, encoded key factor for RSA. And another thing that I'd like to show to you guys is there's two modes to do public key encryption. One is with RSA, the other is with Diffie-Hellman. So what's the difference between those? With Diffie-Hellman, you establish a key agreement between two parties, and they have a shared secret key. So I send to you my public key, you send to me your public key, we establish a shared key based on your private key and on your private key, on your public key and my private key. And based on this agreement, we generate a shared key, both encrypted. In this way, we do not expose even our private key or shared or public key, because this shared key is ephemeral. So at each key agreement, it will generate a new shared secret. So it looks like this. Is a little bit longer. So I specify my algorithm here is Diffie-Hellman, and I initialize with the size of my key. I have a Diffie-Hellman parameter spec that's just bureaucracy. The API is not amazing. And I have a key pair generator here with Diffie-Hellman. I initialize it. I have a key pair for Alice, a key pair for Bob. And here, like I mentioned, we establish a key agreement, right? So I have a key agreement here that Alice will get her private key and Bob will get his private key. So during this time, the do phase, we have our public key, right, to generate the shared secret. And based on these shared secrets, I could, for example, make use of CBC, GCM, and CTR, for example, to encrypt data, like it was symmetric encryption. Okay? Okay.
Those shared keys that were generated, Bob's and Alice's shared key, they won't be the same, will they?
They won't be the same. The shared key will be the same for both, but the shared key won't be transmitted over the network. That's the thing about.
So will Alice's shared key that she created with her be the same as Bob's shared key that he created with his private key?
I'm sorry, let me just finish and we'll open for questions. I'm almost done. So, sorry guys. So one thing that, one of the codes that I like is that privacy is not only for us developers, is for ordinary people only to respect the dignity. And I think that everyone should be aware how to encrypt the data. It doesn't matter of the level of knowledge. It's not a thing only for experts, okay? I would like to thank you guys because probably it's late and for listening about cryptography. Thanks very much.